The universe is vast and full of wonders. It stretches beyond our imagination, filled with countless stars, galaxies, and cosmic phenomena that boggle the mind. Each star, each galaxy tells a story of creation, evolution, and sometimes destruction. Among these countless stars, one particular star holds a special place in our hearts and minds: our Sun. Billions of years ago, our solar system, the Sun, and everything that orbits it, was just a cloud of gas and dust. This cloud, known as the solar nebula, was a chaotic mix of particles swirling and colliding in the vastness of space. It was a time of great turmoil and potential where the seeds of planets, moons, and other celestial bodies were sown. This cloud is called the solar nebula. It was a vast, colorful expanse of gas and dust, illuminated by the light of nearby stars. The solar nebula was a nursery of sorts, where the building blocks of our solar system are formed. Within this nebula, countless particles of dust and gas began to clump together, driven by the force of gravity. It was a tiny part of a much larger cloud. This larger cloud, known as a molecular cloud, was a region of space where new stars were born. Within this molecular cloud, pockets of gas and dust began to collapse under their own gravity, forming dense regions known as protostars. Our Sun was one of these protostars, destined to become the center of our solar system. Imagine a swirling mix of tiny particles, like dust bunnies in space, ready to be transformed. These particles, though small, held the potential to become planets, moons, and other celestial bodies. Over time, these particles began to stick together, forming larger and larger clumps. This process, known as accretion, was the first step in the formation of our solar system. This is where our story begins, the story of our solar system's birth. From a chaotic cloud of gas and dust, a beautiful and complex system of planets, moons, and other celestial bodies emerged. Our Sun, once a protostar, became the shining center of this system, providing light and warmth to the planets that formed around it. This is the story of our cosmic beginning, a tale of creation and transformation that continues to unfold to this day. The solar nebula was not just any cloud. It was made up of the leftover material from the Big Bang, the event that started our universe. This material, mostly hydrogen and helium, swirled around in space. It also contained tiny amounts of heavier elements, like carbon and oxygen. These elements are the building blocks of planets and even life itself. Over millions of years, gravity started to pull the particles in the solar nebula towards each other. Gravity is a force that attracts objects with mass. As the particles came closer, they bumped into each other and started to spin. The cloud began to flatten into a spinning disk. This spinning motion is similar to what you see when you make a pizza dough spin. At the center of this spinning disk, the material became denser and hotter. The temperature and pressure at the center became so great that the hydrogen atoms began to fuse together. This process, called nuclear fusion, released an enormous amount of energy. And just like that, our Sun was born. Section 5. From dust to planets: accretion in action. In the vast expanse of space, the process of accretion is a fundamental mechanism that transforms simple cosmic dust into complex planetary systems. While the Sun was forming, the leftover material in the disk continued to spin. This spinning motion caused the particles within the disk to collide and interact with each other, setting the stage for the birth of planets. The particles collided with each other, sticking together and forming larger and larger clumps. These collisions were not random. They were influenced by the gravitational forces at play within the disk. As particles stuck together, they created a chain reaction, attracting more and more material. This process, called accretion, is like rolling up a snowball. It gets bigger as it gathers more snow. Imagine starting with a tiny snowflake and rolling it through a field of fresh snow. With each roll, the snowball picks up more snow, growing larger and larger. Similarly, in space, these clumps of particles grew as they gathered more material. Over time, these clumps grew into planetesimals, the building blocks of planets. These planetesimals continued to collide and merge, eventually forming the planets we see in our solar system today. The process of accretion didn't stop there. It continued to shape the planets, moons, and other celestial bodies, influencing their composition and structure. The early solar system was a dynamic and chaotic place, with countless collisions and interactions. These interactions played a crucial role in determining the final arrangement and characteristics of the planets. Some planetesimals were ejected from the solar system, while others merged to form larger bodies. Our own planet, Earth, went through this process. It started as a collection of dust and gas, gradually growing through accretion. As it grew, it experienced intense volcanic activity and collisions with other planetesimals, which contributed to its current composition and structure. One of the most significant events in Earth's history was the formation of the Moon. According to the giant impact hypothesis, a Mars-sized body collided with the early Earth, ejecting material that eventually coalesced to form the Moon. This event was a direct result of the accretion process and had a profound impact on the evolution of our planet. Today, we see the results of billions of years of accretion in the stable and diverse solar system we inhabit. From the rocky inner planets to the gas giants and icy bodies in the outer reaches, each celestial body tells a story of its formation through accretion. As we continue to explore space, understanding the process of accretion will help us uncover the mysteries of planet formation and the evolution of our solar system. Future missions and observations will provide new insights into this fundamental process, revealing the intricate dance of particles that gave rise to the planets and moons we see today. Section 6, Inner Verses, Outer, a Tale of Two Worlds. The solar system divided into two distinct regions, the inner solar system and the outer solar system. In the inner solar system, closer to the sun's heat, only rocky materials could withstand the high temperatures. These materials form the inner planets, Mercury, Venus, Earth, and Mars. Section 7, Moons and More, the supporting cast. As the planets formed, they exerted their own gravitational pull. This pull attracted smaller objects, like asteroids and comets, capturing some of them as moons. Our own Earth acquired its moon, a constant companion in the vastness of space. These moons added to the diversity and beauty of our solar system. Section 8, Comets and Asteroids, Leftovers of Creation. Not all the material in the solar nebula ended up in planets or moons. The solar nebula, a vast cloud of gas and dust, was the birthplace of our solar system. Over millions of years, gravity pulled this material together to form the sun, planets, and moons. However, not all of it was used in these formations. Some of it remained as asteroids, rocky remnants from the early solar system. These asteroids are primarily found in the asteroid belt between Mars and Jupiter. They are like time capsules, preserving the conditions of the early solar system. Each asteroid is unique, with its own composition and history, offering a glimpse into the processes that shaped our cosmic neighborhood. Others formed comets, icy bodies that traveled from the outer regions of the solar system, leaving trails of gas and dust as they approached the sun. Comets are often described as dirty snowballs because they're composed of ice, dust, and rocky material. When a comet gets close to the sun, the heat causes the ice to vaporize, creating a glowing coma and a spectacular tail that can stretch for millions of kilometers. These leftovers provide valuable clues about the solar system's early history. By studying asteroids and comets, scientists can learn about the conditions that existed over 4.5 billion years ago. These small bodies are like ancient messengers, carrying information about the primordial materials that formed the planets. Missions like NASA's OSIRIS-REx, which collected samples from the asteroid Bennu, and the European Space Agency's Rosetta mission, which studied Comet 67P/Churyumov-Gerasimenko, are helping to unlock these secrets. The data gathered from these missions is crucial for understanding the origins of our solar system and the processes that led to the formation of Earth and other planets. In essence, the study of comets and asteroids is a journey back in time, revealing the story of our cosmic beginnings. Section 9. A solar system in motion, a delicate balance. The planets, moons, asteroids, and comets in our solar system are in constant motion. They orbit the sun in a delicate balance of gravity. This balance has been maintained for billions of years, allowing life to evolve and thrive on our planet. Section 10. Conclusion. Our cosmic oasis. The formation of our solar system is a testament to the power of gravity and the incredible processes that shape our universe. From a simple cloud of gas and dust, a star was born, and around that star, a system of planets, moons, and other objects came into being.